Okay, everyone, we are back for the second presentation, and we're talking about 3D printing Lego compatible gadgets. I'm super intrigued with Tech Wookiees, Paul, and Willie.
Yeah, so thanks. We've been working on something deep in the labs, and to follow up on Ikke's nice presentation, we have tech that isn't available anywhere else in Finland. So hopefully we can get that out. We've actually shown this in Norway and London and are using it with customers, but we don't have details that we can share at this time. The general summary is most prototypes look kind of like that. And we're trying to get away from that and make everything clean. So the desire is to snap together your prototype with Legos. And here's one of the examples. We have the self-driving car. We'll go through that more later. So by snapping together the wires and the physical prototype, we should be able to make things smarter than we have in the past.
All right, yeah, just quick content overview. First, we're gonna see like, what's this all about? What the hell are Pella Blocks? Why? what are we solving here? Where's the pain? And we have a little case study, the car we just mentioned, and then like, what's next? Where can we go forward with this? Pella Blocks are self-locking blocks. That's basically anything that clicks together. Lego, Mega Blocks, whatever you had in your childhood. Like that guy on the right over here, this is a Pella block, and they're parametrically generated, they're 3D printed, that's what makes them special, you can just print them yourself. And of course they're made by us, and open source license, because that's how we do. So, what is it again? Any shape, any material, and things you can't buy in the store. So this is like something I made out of Lego, and then something we printed from Pella to replace that. And what else? Like, it's not just blocks. It's also like you can incorporate electronics. So we have a Raspberry Pi case here, compute stick for ESP32. I think that's Kenta's favorite. And basically, you can, what do you say? You design things and you use these for rapid prototyping. So it's more than just service design. You can actually do rapid hardware prototyping with this. So last I mentioned it was parametrically generated. So as we can see here, these are 3 parameters, and that's all you need for this block. So we've got 4, 4, 2, width of 4, length of 4, height of 2. That's all you have to enter, no 3D modeling, do nothing by hand. And how that works itself, there's an OpenCAD running in the background. It's also an open source CAD program, and Paul can tell you more about that later.
Yeah, so how did this get started? We, in the past, together with Ricardo, created the IoT service kit. And that was just a designer and an engineer who kind of hated each other and then worked it out, and now we like each other. By combining those two viewpoints, it's a system that you can use in early stage for working out the service design, but what we were lacking was the next step. How can we use the futurized way of doing lean service creation and take it into making physical services, not just another boring website? And as we go forward, I only agreed to do this if I was allowed to insult the audience. The biggest question we get is why? What does this have to do with our business? But we don't define ourselves as the boring website company. We define ourselves as creating digital services and being leaders. And that is what we like to offer to the world, and we do that with permissive open source and by example. So 3D printing physical things doesn't scale. Yes, I'm not going to print these in mass. I'm going to make one, and I'm going to test the concept as quickly and cheaply as possible, and I can even reconfigure it in the field. And that's the point. Once your service has gone through several iterations like this, then you can lock it down and make something that is production ready. But in the functional prototyping early stage, we don't actually care what it looks like. We built some interesting things for the office together with Kenta, who's sitting here. We have our own internal navigation system with Bluetooth and some scary looking sensors in the bathrooms, and a number of other things you can see at the website. But what we found is that it's actually a little bit difficult to get designers to make those things. We had to do a lot of that ourselves, and so we would rather snap it together, design it once. That's sort of the engineering idea. Why? Well, the big goal, the next step for us is to take this and use it with embedded machine learning. On the left, you see the speaker for your home, which you can use, and it's got an array of microphones. In my hand, I have the version that we 3D printed, and it has a board from China. And if you peel the top off, you'll see it has 6 microphones in there, and you can use that with Alexa or Google or your entire own separate system. Does anybody know what that is on the right? It's a deluminator. This is what Dumbledore uses to turn the lights on and off nearby. So the sorts of things we're talking about are hopefully not dark magic, but based on where you are, the context you're in, it might be a whole lot easier to use this than to go to a website or go to a text interface and start typing something to make those things happen. So the user experience is central to why we're looking at these, and the main point of a large part of what we would do with machine learning inside of these blocks. Another inspiration was working with a large car company. We have several as clients, and their internal processes are, let's say, not the same as what we do in software. So they manage complexity by redesigning every part over and over again by hand every time the 2 parts are too close and they bump into each other. That's a daily cycle. It goes on and on. It costs them a lot of money. And I was thinking there has to be a better way. Using parametric design, we should be able to just say the minimum clearance is this, and the computer figures it out and modifies the design or tells you that it can't meet those specs with the constraints provided. You get a mental image of the car, and we just say, oh, we need to have at least 10 millimeter clearance around the shocks, and it does that for you. Nice concept. Not so easy to do. A good example of parametric design is from architecture. The ceiling of this airport is an algorithm, which has been usually printed, but there are other ways of manufacturing those. So we're using parametric design with Legos. This is a Pella block, just a basic traditional block. This is a much more capable, it's a combination of Lego and Technic holes. You notice the knobs are a bit taller. This is optimized for 3D printing. If you look down inside, there are a number of features such as this little ridge that help it connect better. Printers are not as precise as injection molding. It wasn't even clear when we started that we could make this and get a nice tight fit, but we can, and we'll show you how. And then we end up spending a lot of interest in, for example, a PIR sensor detects motion. You can just drop that into a holder and use a couple of Technic bars to hold it in place. And now you have your Raspberry Pi or PIR or whatever sensor you want connected. And the point is you can reconfigure that in the field. You don't have to make a new enclosure to change the physical or the electronic parts there. A lot of boards. The Node MCU is a favorite for many. It's quite inexpensive with Wi-Fi and sometimes Bluetooth. This is the sensor we had for the seed speaker mounts there. You'll notice that one's printed in thermal polyurethane or TPU 95. So it is completely flexible and very tough. And the way that we make these fit precisely is we have a calibration system. So you print out this calibration block, and then you take traditional Legos and you test fit the top, the bottom, the sides. And those three numbers tell you that when I print with this plastic on this printer, then I'll get a nice fit using those three parameters. So that's a system that hasn't been done elsewhere to the best of our knowledge. Does anybody know which of these is the original Lego block? Who thinks it's 1934? 47? The second one? 49? 77? 49. If you look closely, it says made in England, 1947. These two are identical. This is Danish innovation. They've done a lot of things since then, but the original is part of a long stream of concepts, and then they have added the Technic holes, etc., in the distant past. We're continuing that tradition, and we don't have any direct profit motive here. Everything is completely free.
Okay, promised a case study at the beginning. Well, this is still a work in progress, but the hardware part is coming along pretty nice, even if the software, everyone's still working on it. So sometime last year, we came up with the idea to have a car competition with Tampere. Now, what did Tampere do? They went fancy. I mean, look at this guy. It's like if James Bond starred as the Batmobile, this is what it would look like. But if Tampere wants to do fancy, I guess then that leaves us to do scrappy. So that's how all of this started. Like Paul had Pella Blocks. We were looking for a way to build the car. And then the first thing we did was we put these nice large Lego pieces here. They're not available in stores at all. So we 3D printed them custom just for this car. And then we had a nice hardware platform. And at this point, if you exclude the electronics, that was the hardest part of building the hardware. So what we did was we put our tools away and we got our best and brightest to work on this.
That means Willie, I think. Yeah.
Yeah. No. Yeah, so you can decide which one is the best and which is the brightest here. But yeah, pretty much. So this has a lot of benefits now. You can see they're just sitting there building. There was a crash during the test. They're not having any tools. They're sitting there rebuilding it. They don't have to make a new 3D print. So I'm not saying it doesn't break. I'm just saying when it breaks apart. So you can just reassemble it. You don't have to start over. Yeah, so what are the main benefits now? Like compatibility. I think if I look right here, we have, I don't know, 1, 2, 3 unique Pella blocks. And the rest, 4 if you include the camera, and the rest is just straight out of the store. So you print a couple pieces, and then you can build, iterate, etc. Easy to use. Things just fit together. Anyone looks at this, even if they haven't played with Legos before, they can kind of figure it out. Flexible. For example, you just exchange a piece if you don't want it. This camera mount right here, you just remove the pin. You can change the camera angle at any time. You don't have to print a whole new camera mount. And it's also literally flexible, like our bumper. It has a lot of flex. And it's, yeah, reproducible. If I gave someone this car right now and a box of Legos, they could rebuild it, copy it, and then modify it for whatever car frame they have. So what's next?
Well, we have just released it. You can actually find everything that we have done so far live on the website. You go to the website and download or git clone, and you get all of the models, which you can open up in OpenCAD, which is free software. There's a new preview release of that, which is significantly better than what you might have tried if you've tried this software in the past. In particular, it has a customizer here. So I can modify this live just by dragging, and now I can cut into the block and see the internal structure. I can drop down here and I can specify, I'm going to print this with ABS. And it's going to modify very subtly the size of the holes in the side, the top knobs. Those are calibrated based on the numbers you provided. We have our pre-calibrated numbers for our TAS printers included as a reference. You can change the length. Let's say, oh, I've got a different size PIR sensor. I want it to be a bit longer. I think actually need a little bit of extra space on the width dimension in the support. I can make that, I can change the twisting, where the holes are in the side. I can make the fit a little bit tighter. It doesn't take any coding to do this. And this is the way that most of us would like to use it. You just use the model that's there. For example, a Raspberry Pi model that some of you are looking at. And if it doesn't fit quite right, you can tune the numbers, or if you have a slightly different board from the ones we've provided, it's a matter of sliding things around. And then from this software, you can actually directly print if you've set it up that way. It is not complicated to use. The key again is you must calibrate, otherwise the fits will be just like some of the Legos that I bought from China. They fall right off. They're not calibrated. I think that it probably was at some point and they didn't update their dies as quickly as they should. And I have a nice truck and the wheels fall off of it, so I had to glue them on. Hopefully you can avoid some of those issues.
Yeah, and all of those changes you just showed, they would take hours with a CAD program, by the way.
Yes, and that is what we mean when we say parametric. We mean it is customizable and it tries to make logical assumptions about how those physical changes combine to give you a meaningful shape. You can make useless things with that. We haven't covered all possibilities. But the code behind it is a scripting language. We don't have time to complain about that and praise it. I'll say that we did have some nice comments. Does anybody here know who is Steve Klabnik? He wrote the book on Rust. So if you are using the Rust language, you're reading his book. And he said, this is awesome about this project. I created a simple Rust program as a parallel build system for OpenCAD because it was taking me 6 hours, and now it takes less than an hour to build all the models. Most users don't have to do that, but since I'm uploading them all to the web, every time I iterate, I want to see that result. Of course, when you put that online, someone posts a one-line shell script that does the same thing as my 2 or 3 page Rust program. Almost the same thing, but the difference is minimal. So this is life, and it's all good fun. We'll continue to add a few models, but now it's really time to use it. Stage 1 is to get the physical system working and reliable. We've proven that it can fit very nicely, and you can print with flexible materials for your bumpers as you wish. Next is to focus on the software stack. So getting the machine learning inside a self-driving car, inside of a smart speaker, which is entirely privacy preserving. These are the areas that we will focus on next.
Yeah, so let's take a question from Helsinki first, and if you're remote, just hold your question, maybe write it down, and we'll do a remote question next. Are there any questions from Helsinki? Yes.
Number one, this is awesome. Number two, I currently happen to be working with Lego, the company, and I know that they're ruthless about their brand and their kind of like licensing kind of things. They sue every company that tries to do anything Lego compatible.
Yes.
Have you considered, how his future is going to get sued over this?
I thought about that a lot. I did my research. They are ruthless. They've tried, for example, suing under copyright infringement in the US against a Canadian company and others. They've lost every time. If we did Lego Batman, they would have good grounds to complain. But what we have done is essentially what they did when they founded the company, which is based on, in our case, very old technology. We're talking about things from 1949 or 1947 in the UK. Nothing we do is new here, and it's available online from a number of companies in the West legally. We don't want to interfere with their business. They make their money off of branded content. And if you want something good, buy it in the store. Don't waste your time printing it. If you want something which, let's take for example, I want an extra long drive shaft, or I don't happen to have one at home. Those models are there, but those are not really the main point. If I want that drive shaft to be flexible so that I can do something strange, then you have some interest in making your own. But it is more work to do it this way. It is not more cost effective. Definitely buy any Technic pins that you can and other parts from them. And this is, for example, a combination of Lego parts and 3D printed parts. We only print the things like this angle connector or camera holder or Raspberry Pi holder, which we need to, or if we want to vary the material properties to make it extremely tough. To give you an example of tough, first start with, can you break that? Just snap it. It's okay. Yeah, not too hard. That's a typical 3D print with some of the materials that we use. Lego uses ABS, and we can print very strange shapes that you will never find in a store. Now, let's take a look at, I think that's even the same model. Can you break that one? That's thermal polyurethane. Here I have a TPU cover on an Intel Compute Stick case. I'll buy a 6-pack to anyone who can rip that with their bare hands. It is basically indestructible. This is nylon. I'll buy you a bottle of whiskey if you can break that with your bare hands. You can even use your teeth. But you can do things very, very different, and a lot of these parts are not in the store. That's a robot finger from a prototype we're working on. So it is for makers, and it's for fun, and it is to get past what you can get from Lego, which is a bit limiting. This is not a Raspberry Pi. You don't make self-driving cars out of this and expect them to have machine learning in the box. And that's why we're here.
All right, if you're online and have a question, please unmute and ask the question. Maybe from the competing robot AI car office, perhaps? Has anyone broken any of the Pella Blocks? Did anybody win the 6-pack? No.
I realize we have a history of not succeeding against Tampere, and I told them that they needed to ruthlessly tease us to keep us motivated, and they took that to heart, abusing us at every possible public occasion. Let's see what happens when the race comes in Tampere at the next Futu event this summer. There aren't any signs that they're ahead, but they could be modifying what they present to us.
Sounds like a challenge.
Okay.
Are there any questions online? Maybe we have time for one more. Otherwise, we'll end. Okay, thank you for your presentation. Thank you everyone for coming. This has been Tech Weeklies, and please come again next time.
Yeah, just one thing at the end. We're on Vimeo, YouTube. We have a nice video of how the car is built. Blog posts, futurist.com/blog. It's right there. And of course, pellablocks.org if you want to try these out right away. And for anyone here from Futurize, if you have, I don't know, any wishes, hardware, you want to prototype some IoT stuff, just let us know. We'll get you started with this.